The objective of this video is to use a variety of strategies to solve hexadecimal related problems. So this is probably one of my favorite lessons of all time just because I love hexadecimal. I don't know what it is about it. I just think this is a fascinating number system, and seeing how easy it is to translate hexadecimal to binary and then to decimal, that just brings joy to my heart. So I love hexadecimal. When you think of hexadecimal, I want you to think of it as binary's best friend. So without binary, we wouldn't have much of a need for hexadecimal. Friends are supposed to help friends, and hexadecimal helps binary express itself to humans. What would you rather read, 101000101 or A5? So when we are doing our translations from hexadecimal to decimal, I want you to include binary. That way we have 3 friends, not just 2 best friends, okay? So think back to hexadecimal. We have the number 5F here, and in binary form, F is the number 15 in decimal, right? So if you do a quick mental translation, 15 in binary is 1111, right? So you got 1, 2, 4, 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So F is 1111, 5 is 101. So that's a 1, nothing in the 2's place, 1 in the 4's place. So now you just erase this little line, combine the numbers right here. So you got 1 in a 1's place, a 2, a 4, an 8, a 16, and a 64. You add these together. Super easy, and I came up with this idea called Mr. Hex Steps. So if you're a memorization person, this would be a great thing to memorize. The first step is you split the 2 digits. If there's more than 2 digits, you just split them. So if there's 3, split all 3. If there's 10, you split each one up into a 4-bit section here. So each one hex has 4 bits in it. Then you convert from the hex, if necessary, to binary. Then you convert from the binary to decimal. To figure out the decimal, you erase that split, put all the binary together, and then add them up. And so far, after 2 months of teaching students how to use hexadecimal or how to figure out the decimal from the hexadecimal, I think step number 5 is the number 1 messed up step, okay? So it's simple addition actually that I see the most problems with. So just, check your work right there. While we are talking about easy ways to remember to do things, I wanted to mention this OSI Network Model, and this is a question I found on Albert, so it's likely to be a question on the AP exam. Now we'll talk more and more about networking as we go, but just check out this easy to remember way to memorize the OSI network. The first option you have is people don't need those stupid packets anyways, since networking deals with packets. But networking isn't all packets, so the second one is even better. Please do not teach students pointless acronyms. That one's my favorite. And then number 3 is what it actually stands for. So the physical data network transports the session presentation application. Like, that'd be great if you could memorize it, but the P in please is for the physical layer, the data layer, the network layer, transport layer, session layer, and then presentation layer. Oh yeah, don't forget application layer. Okay, so of the 3 I gave you, actually, which one of these do you like the most? Another advantage of hexadecimal is you can easily visualize the size and thus the limits of the data. So here's a practice question from the test. Given the bitmap, what is the correct hex? So 1, 2, 3, 4, 5, 6, 7, 8. Each row is 8. 1, 2, 3, 4, 5, 6, 7, 8. So the row is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's an 8 by 8 square. If each hex has 4 bits in it, so 4 bits plus 4 bits, so this must be the row. So thus row 1, row 2, row 3, right? Row 1, row 2, row 3. You don't have to color in for every single one of these. You just have to figure out which one is wrong first. So I see the first row is blank, and that's 0, and that's 0, and that's 0. So far so good. The second row is blank, so that's 0. The rest have numbers, so there's some sort of value to it, and so I know A is right, like right away. And then it just makes more sense as I see 18, 18, so this is colored. So right here, 1 in the ones place, going up here, this is the 1, 2, 4, 8. And then right here, 1, 2, 4, 8. Okay, so 1, 8. Get it? And then take that and think about what it meant to be an artist for some of the older games. Like this is Mario. Creating Mario must have been a painstaking process. Since I'm talking about hexadecimal, there is this concept called 2's complement. I think it's fun, but it's not needed for this test. I just felt really guilty going over, this lesson right here and talking about hex and binary so often without ever mentioning 2's complement. So here's some information on the slide, right, for you to read if you are interested, but the rest of your research there will have to be on your own. Essentially, though, 2's complement is where you flip the bits and add 1 to create negative numbers. So if you ever thought about that to yourself, how does binary or hexadecimal represent negative values? There you go. And there's one more thing I need to mention, so, fast forward or pause it if you don't like this. What is the 2's complement hexadecimal number? 0x FC in decimal. So there's the answer right there. You just invert it. Invert meaning like the exact opposite. So instead of saying like the binary here is 1, 1, 1, 1, okay, the binary is 0, 0, 0, 0, 0, and then that's how I'll know it's negative. And do you see the connection right there? So it says 0b and then the binary number. Right here it says 0x and then the hex number. Okay, I'm done talking about things that actually will not be on the test. All right, so moving on. Using an ASCII table, what is the hexadecimal series of numbers for the word JPEG? So J, I find J here. This is the hex. This is the decimal. The question says, what is the hexadecimal? So J is 4A. It's one of these three. P is 50. All right, so it's one of these two. 45 or 42, so E. 45. All right, so it's C. Correct answer is C. All right, so wrapping up here, ASCII is an encoding for letters and symbols. We use hexadecimal numbers to also represent color. When a person wants to refer to a specific color, they can give a series of 3 bytes or 6 hexadecimal numbers known as a hex code. So for example, army green is 75, 83, 32. 75 red, 83 green, 32 blue. Or the hex code looks like this. Hashtag 4B5320. You might see hexadecimal in this format as well, especially when referring to memory addresses. And I go over this really well in my web design class. A memory address is very much different than processing. Okay, in computers, you have storage and you have processing. If you want to get more technical, you also have the input and outputs, but these 4 things are basically like what a computer is. So my think right share here is, what is the hex code for orange if the decimal is 255, 125, and 0? Hint, we can't really say reverse, Mr. Hex Steps, but just look at this image right here, and that should help you. It's not a complete reverse. Seeing how I gave you the decimal number, now you come up with the hex. Those numbers, again, are 255, 125, and 0. Another check for our understanding before we get to the DOL. Give me the hex code to your favorite color, please. And here we are at the DOL. I hope the test will give you an ASCII table, and if not, be ready to make one yourself using a snippet of one. So a lot of these hexadecimal questions I saw in Albert were related to ASCII values. Here's one such example. It says take the ASCII for the word CPU, add the hex code 2F1724, and then write the resulting word. So since I saw this on Albert, I thought I'd make it the DOL for today. I'm telling you a hint right here. You could Google ASCII table to convert 2F1724 to decimal quickly, and then add these numbers. Then connect the sum to each column that create ASCII letters. And usually there's a nifty little pattern to that. And again, I saw this on the test, so you very much may need to practice adding hexadecimal numbers on the actual AP exam.